All right, I've had a question about number 5 in lesson 1 for physics here, and initially this looks like a very simple question, but in reality, A part's actually very tricky. So we have the constant, a car travels up a hill at a constant speed of 10 meters per second. So I'm going to go with, write down my two pieces of information. So I have uphill. So we don't really know how far the car goes up the hill. We know its velocity is 10 meters per second. And then we're given downhill information. Again, we still don't know the distance traveled, but we know the velocity down the hill is 20 meters per second. So if the turnaround time is ignored, so that just means at the top of the hill you instantly start going down the hill, what's the average speed for the trip? Well, we know that VAV is your total distance divided by total time. So in both cases, we don't really know what the distance is, but we can find it out since it's a constant velocity. So for the uphill, we'll say d1 equals v1 t1, because that's the uphill information. You could use u as a subscript. I don't know my d1. Velocity 1 is 10, and I don't know how long it took to go up the hill. Now, I really can't go any further at this point, so now I'm going to go to my downhill information, and I see that d2 equals v2 t2. Again, I don't know how far down the hill it went. However, I know the velocity. I don't know the time. The key to this question is realizing that d1 equals d2. They had to travel the same distance down the hill as up the hill, which means we can get a proportional relationship. So 10t1 equals 20t2. If I divide both sides, it doesn't matter which one you isolate for, I'm going to get t2 by itself. So that means that 0.5 t1 is going to equal t2. All right, so it took half the time to come back down the hill. What that allows me then to do is go back to our formula for average velocity. I might know my total distance. I'm going to do this in a ton of steps to hopefully make sure it's clear. It's going to be d1 plus d2, and total time is t1 plus t2. From over here, we have got d1 and d2. If I can do that substitution, 10t1 plus 20t2 over t1 plus t2. And now I'm going to get it all to one variable. So that means I'm going to replace all my t2s. So from down here, I'm going to replace all my t2s with half t1s. So 10t1 plus 20 times 0.5 t1 over t1 plus 0.5 t1. So we end up with, when I simplify that, half of 20 is just 10, so it's going to be 20 t1 divided by 1.5 t1. T1s will cancel out. 20 divided by your 1.5, and you can double check this, but I believe it's 13.3. All right, so that's how you calculate average velocity or average speed here. Again, it's a lot trickier than it looked. I thought it was a pretty simple question until I started into it. So average velocity is 13.3 meters per second. Now B part, it wants to know what is the average velocity. So again, it's just testing your understanding of the definitions. So B part, average velocity, so now it's a vector, so I put the hat on top. And it's your total displacement this time over total time. So in A part, we were looking for total distance. Now we're looking for total displacement. Well, in this case, the car returned to its starting location, so total displacement is 0, and we already know the total time was 1.5 t1, which doesn't really matter. So it's going to be at 0 meters per second, and you don't really need to take you can put a direction in, you should because it's a vector, but it's 0 meters per second. All right, so that is how you do this question. If you have any other further questions or follow-ups, just let me know.